more. Okay. Anyways, sinusoidal word problems. Recall sinusoidal functions are you have to be comfortable with the word periodic, and that means that patterns will repeat. They're cyclic. Okay. There's a cycle. That's another word for it. So the height of a seat on a Ferris wheel, right? Ferris wheel, if you measure the height of that seat throughout your ride and just keep going, it'll be a sinusoidal wave as time goes by. The average temperature for a full year probably will be a sinusoidal wave. The time or depth of the ocean tide, etc. The hours of sunlight per day, it's a sinusoidal wave, right? So a lot of things have a sinusoidal pattern. Here is some important information. When it comes to a wheel, okay, this is specific to a wheel. A is the amplitude, which is the radius of the wheel. Okay, I will show you in a bit why. The diameter of that wheel will be 2 times the amplitude. Just think about it. If the radius is the amplitude, then the diameter would be 2 times the amplitude. Okay? Period is the amount of time along the x-axis for the pattern to repeat. I would say this. Can you just make sure you is the amount of units, I didn't say time, the amount of units along the x-axis for the pattern to repeat. It could be, example, the time it takes for the mark on a tire to go from the lowest point to the highest and back to the lowest point. So let's consider this wheel here. So let's say, just for illustration purposes, you make a mark on this wheel at the very top of that wheel. Okay? And let's say this wheel starts spinning, okay? So you would get this point as it turns would end up at the middle height, the middle of the tire, like that's the center of a tire. As it keeps turning, it would get to the low point. It keeps turning, it would go back up to the middle, right? Remember, this is going around this wheel, but we're doing this as time goes by. And then one more time, you would return to the highest point where you started. And if you connect these, okay, you get one full cycle here. Okay, this is the period. Okay. This is the amplitude. From the midline to the lowest is the amplitude. It would also be from the midline to the highest point would also be the amplitude. But we also, because it's a wheel, in this case that would be the radius of the wheel. The distance between the midline and the lowest point is the radius of this wheel. Okay, and if you wanted the diameter, you would do 2 times the amplitude. Okay, so there's that. If you want to, this is also the amplitude right there. One full rotation. That's what I'm going to say here. And can I say another thing here? This is important. I'm going to use a blue pen for this. If you don't have a different color, that is fine. But there's something unique about sinusoidals. If you were to take the starting point to the end point, and you kept track only of the high, the mid, and the low, okay, of those particular points. Obviously, that mark on the tire can be at any height, but it turns out that you can quarter this. You can split that period into quarters. Right? So this would be period divided by 4, period divided by 4. So what I'm saying is that from your starting point, if you take a quarter of a period, you're going to end up in the middle, mid-height. If another quarter of a period goes by, you'll be at the lowest. Another quarter, you'll be back to the middle. Another quarter, you're back to the full rotation. You're back to the top. So there's something that happens, right? When we only look at the high, the mid, and the low, we can divide our period into quarters and then actually know what the x values will be here. Okay, so let's say it takes 4 seconds for this tire to turn. It'd be a very slow rotation, right? 4 seconds. 1, 2, 3, 4. If you take 4 seconds and split it into 4, that means it would take 1 second for that mark on the tire to get to the midpoint. It would take another second to get to the lowest, another second to get to the mid, another second to get back to the highest. Okay? If my period is 8, let's say it takes 8 seconds to rotate, even slower. You split that 8 into 4, right? Go 8 divided by 4. That means it takes 2 seconds to go from the highest to the mid, another 2 seconds to get to the low, another 2 mid, another 2 to get to the highest, right? I hope you get the idea here. Okay. Let's talk about this here. This is just for your information. Okay. If a sinusoidal function has a min, so this is a point, right, of 2.8 and a max of 512, determine the midline, the amplitude, the period. Let's do a little sketch for this. A min, obviously we're here. That's 2.8. So an x value of 2, y value of 8. Then we get to the max of 512. So you almost have to imagine they're giving us a partial picture. They're giving us this, right? The min and the max. But you have to think, technically this keeps going, right? This is just a never-ending sinusoidal wave. I've just given you this, and I've given you that. Okay. What would be the midline? The midline is what cuts this in half. How would I find out my midline with this information? Do you remember the formulas I gave you to extract information from a graph? We know that the max is 12, like in terms of like the highest point, and the minimum, the lowest it ever gets is 8. So there's something we can do with these two numbers to get our midline. Do you remember that? Midline is max plus min divided by 2. Or you can guess. If you're pretty good at guessing, what's it between 8 and 12? You can do it that way. So that'll be 8 and 12. Remember, everything has to do with y values except for the period. That's where your x values come in. So this is 20 divided by 2. So it's 10, right? So the midline is 10. Sorry, it got very messy. Too messy here for my liking. But I use that formula. I know that the min and the max are 8 and 12. I add them and divide it by 2. You're basically finding the average between the two. Okay? So the midline is 10. The amplitude, I don't know if you know the formula. If you have it on your study sheet, it's actually max minus min divided by 2. Make sure you do that in brackets first, right? So we go 12 minus 8 divided by 2. That's 4 divided by 2. That's just 2. So the amplitude is 2. Let's put this to the test. Am I doing this right? Technically, we told ourselves that the midline is at 10, right? Does it make sense that if I add 2, my amplitude is 2, right? If I go 10 plus 2, I get to 12. If I go 10 minus 2, I get to 8. So the amplitude is like an elevator, right? It can get you up or down. Okay? What is the period? This is the one I'm really curious. Period is technically, do you remember the formulas? Probably not. But the period is technically if you subtract the x values between two lows or two maxes. But I don't have that information. I don't have that, right? But if I were to subtract these two, then I have half of a period, correct? So I just have to multiply that by 2 to get me the full period. Okay? So I'm going to use 2 times x max minus x min. 2 times x max is 5, x min is 2, so it's 2 times 3, it's 6 units. That's the period of this particular function. Because it would take me 3 seconds, right, or 3 units to go from here to here. It will take me another 3 to come back to the lowest, and that would be a full period, right? So from here to here, it is 6. This is the period. Okay? I'm making your head spin, right? 10:02. I'm going to leave it there.